All right, welcome to last video of chapter 3. I will have a quick recap video to go over the list of things I would want you to know. But this is going to be a slightly longer video. I want to just get adding and subtracting all into one video, including a bunch of examples at the end. So let's start with just the idea of adding and subtracting fractions as a refresher, because it may have been some time since we did this. So if I'm just dealing with fractions in general, let's say I've got 1/3 plus 1/5, I need a least common denominator, which in this case is going to be 15, or 3 times 5. And to get there, I'm going to multiply this by 5 over 5. I'm going to, excuse me, multiply this by 5 over 3. And then my common denominator is 15, and I've got 5 times 1 plus 1 times 3. This works out to be 8/15. Let's say, however, I got something more complicated, and this is going to get pretty crucial when we're talking about rational expressions. What if I had 1/8 plus 3/20? So my least common denominator comes out of some factoring. 1/8 is 1 over 2 times 4. 1/20 is 1 over 5 times 4. Notice I'm not factoring the 4 because I recognize that the 4 is common to both. So I don't need another 4. I've got it already. What I do need is I need a 2 over here, and I need a 5 over here. So when we're dealing with least common denominators, what you want to do is identify, well, what have I already got in both my denominators? And then I only need to add the things that I don't already have. And it makes life a whole lot easier down the road, especially when we're dealing with rationals. Not so much with numbers, doesn't really matter, except you get big numbers and then they're a pain to deal with. So in this case, I'm going to multiply the 8 by 5 over 5. I'm going to multiply the 20 by 2 over 2. Let me just erase that scribble there that I accidentally put there. And we noticed that my least common denominator in this case was actually 40. And I've got 5 times 1 plus 3 times 2, which is 11/40, which does not reduce. So I'm done with the problem. Okay, so let's talk about rational expressions. The first rational expression we're going to look at is 2x over x minus 1 plus 3 over x plus 5. And again, I'm looking for a least common denominator. And what I notice is that, well, I need an x minus 1 and I need an x plus 5. My least common denominator is going to be x minus 1 times x plus 5. I have nothing common between the two. So I'm going to multiply this one by x plus 5 over x plus 5. And I'm going to multiply this one by x minus 1 over x minus 1. And I get 2x squared plus 10x plus, that's over here. Over here, I get 3x minus 3. And I am all over the common denominator, x minus 1, x plus 5. So 2x squared plus 13x minus 3 all over x minus 1, x plus 5. So here's the thing. I'm not done. Because the question is, then, does this quadratic factor? And if it does, I might be able to simplify or reduce. In this case, I look at this and I realize that two numbers that multiply to -6 and add up to 13, not going to be a thing. So in this case, the answer is no, which means that I'm done except for one little thing. Domain restrictions. X cannot be equal to 1. This is not true when x is not 1. And this is not true when x equals -5. And if I wanted to go a step further, I know that these would both be asymptotes on my graph. Okay, so let's do a more complicated example. X over 3x plus 1 plus 2x squared minus 2 over x minus 5, 3x plus 1. I'll let you pause and just think for a second. What's the least common denominator going to be? Yes, you're absolutely correct. My least common denominator will be x minus 5, 3x plus 1. And I sometimes get students starting out who say, oh, well, I'll just multiply the left by x minus 5 over and 3x plus 1 and the right by 3x plus 1. Well, now you've got a cubic. Don't know how to solve a cubic, but quadratic's easy. So we're going to really try to keep this as simple as possible and minimize that least common denominator. So what have I got? I've got x squared minus 5x plus 2x squared minus 2 all over 3x plus 1, x minus 5. Doing a little simplifying, I've got 3x squared minus 5x minus 2 all over 3x plus 1, x minus 5. With a little bit of thought, I realized that the numerator factors as 3x plus 1 times x minus 2. And this is why I made a big deal out of, hey, let's make sure we factor that quadratic, because when I factor that quadratic, I discover that in fact this simplifies. So this is x minus 2 over x minus 5. We know that x is not equal to negative 1/3. There's a hole right there in my graph, which I might not see if I'm just looking at a graphing calculator. You got to look close and fiddle to see those. And x naught 5, and there's going to be an asymptote right there. Okay, next, let's do one that's even more complicated. What the heck, we're rocking and rolling here. This is going to be example 3, I think. Doesn't matter even if it isn't. And I'm going to give you 3x squared plus 13x plus 4 as the first denominator. And we've got x plus 3 over x squared minus 3x minus 28 as the second denominator. And of course, first thing we're going to do is we're going to factor these denominators. So pause, see if you can come up with the factorization. Okay, so I got 3x plus 1 times x plus 4 for the left denominator. I got x minus 7 times x plus 4 for the right denominator. And look at that. I've already got an x plus 4, which means I don't need another one. Just like on that first fraction that we looked at, I don't need another one. If you're not sure, rewind, jump back to that point in the video. So what do I need? Well, I need a 3x plus 1 in this expression, and I need an x minus 7 in this expression. So I am going to multiply this side by x minus 7 over x minus 7, and I'm going to multiply this side by 3x plus 1 over 3x plus 1. Notice that my least common denominator is red, green, gold, and I've got red, green, gold in each. In fact, I encourage my students to color code these when they're first starting out to help them keep track. Okay, so now we're in a situation where we can do some simplifying. X minus 7 times 2x minus 1. We've got 2x squared minus 15x plus 7. plus, on the right-hand side, x plus 3 times 3x plus 1 gives us 3x squared plus 10x plus 3. And this is all over red, green, gold, x minus 7, 3x plus 1, x plus 4. Now, another common error. Right now, people say, oh, I could factor 2x squared minus 15x plus 7, and they write it as x minus 7 times 2x minus 1. That doesn't help us. That's just going backwards. What I need to do instead is combine like terms. And I've got in the denominator x minus 7, 3x plus 1, and x plus 4. Doing a little factoring in the numerator, I notice I can take out 5 out of each of these, so I get x squared minus x plus 2. I've got the 3 parentheses on the bottom, which I am boringly and repetitively having to write over and over and over again, but hey, that's how it works. That's what we have to do. X squared minus x plus 2 doesn't factor. There are not two numbers that multiply to positive 2. Excuse me, there are not two whole numbers that multiply to positive 2 and add up to negative 1. And domain restrictions, x can't be 7, x can't be negative 1/3, and x cannot be negative 4. And if I cared, I would maybe jot myself a note that these will all be asymptotes, since there are no holes created in this problem. Okay, last example, let's talk about subtraction, because people run into, shoot, I've run out of Jamboard space. Because they only let me have 20. Okay, here we go. Jamboard, new Jamboard file, which is underneath the picture. Okay, here we go. Subtraction. Annoying. Subtraction. Because there's another common error that people make. So let's start with 2 over x plus 4 minus 4x minus x squared over x squared minus 16. Now, you may have noticed something here. Ignore it. Resist. I want to show you how to do this, because what we're going to do is we're going to start by factoring the denominators. We've got 2 over x plus 4 minus 4x minus x squared over x plus 4, x minus 4. Yes, this could be simplified right now, but I don't want to do it. My least common denominator, notice that I need an x minus 4 here. So I'm going to multiply this by x minus 4 over x minus 4. So my least common denominator is going to be x plus 4, x minus 4. So I'm putting an x minus 4 over here. So I've got 2x minus 8 minus. Now, here's where the mistake comes in. Minus 4x plus x squared, because this is really in parentheses. The whole thing is being subtracted. Common error. Watch out when you are doing subtraction that you remember to subtract each item in the second fraction. So back to here, we got x minus 4, x plus 4. Whoops, that was a, yep. Am I confused? Am I confusing myself? No. So I've got x squared minus 2x minus 8 all over x minus 4, x plus 4. Moving to the next page, x squared minus 2x minus 8 factors is x minus 4, x minus 4, x plus 2, and I'm over x minus 4, x plus 4. And once again, there's a 1. And so my final answer is x plus 2 over x plus 4, so long as x is not equal to 4 and x is not equal to negative 4. And of course, there's a hole there and an asymptote there. All right. Now, in case you're wondering what was I talking about when I said, well, look, you could do this, but I don't want to. I had 4x minus x squared, and then I had it over x plus 4x minus 4. And you may have noticed that this is the same as the negative of x squared minus 4x. And that is the negative of x. I don't really need that little parentheses right there. X times x minus 4. And still, since this is all, we're subtracting this. Since this is all over x plus 4x minus 4, we actually could have simplified that right off the bat. But I didn't want to because I wanted to show you the process for subtraction. So a couple quick things, guys. Make sure that you always show the domain restriction for the whole. It's pretty obvious just staring at the answer that x is not equal to negative 4. It's not as crucial that you write x equals x not negative 4 because, yeah, everybody knows that. They can look at that and they can say, yeah, clearly x not negative 4 is not in the domain. But it's not totally obvious that x is not 4 because your answer doesn't say anything about that. Your answer doesn't include the term x minus 4 over x minus 4. So if you just hand somebody this and say, here's what this simplifies to, excuse me, hang on. If you hand somebody this and say, here's what this simplifies to, they are going to draw a graph with an asymptote at negative 4. There'll be some vertical shift. I don't know off the top of my head what it is. I don't really care. So they're going to draw some graph that looks like this. And what their graph will not have is a hole. Because they don't know that there's a hole there unless you tell them. All right. Okay, guys, that's it. This is rational expressions. I'll have a quick recap video that'll come up in a couple days. Of course, if you're watching this, it's probably up already. So I'll have a quick recap video that will go over everything you need to know about dealing with rational expressions. But in case you wanted to move on, simplifying, multiplying and dividing, adding and subtracting are really key to what's going on here. All right.